What we want to achieve is the platonic ideal of the perfect product.
That's why Tesla is doing its utmost to cut waste for many upcoming models. At Giga Texas, 50,000-ton Gigacasting machines turn molten alloy into 3 giant pieces, then snap them together with a structural battery pack. That single move replaces thousands of tiny parts and welds with clean geometry that builds fast and stays strong. When it comes to the 2026 Model 2, this is how a high-teen sticker becomes possible without losing speed, range, or tech. So, what turns fewer parts, fewer welds, and smarter flow into real money off the price you pay? Why does a 4.7-second chassis build matter for volume? And how do copy and paste factory cells keep costs falling after launch? Stay with us as we connect the dots from casting pressure to cash savings, and from factory layout to ownership value. Subscribe and ring the bell, and your support means a lot. Now let's begin. How will Tesla's Model 2 production line put $7,000 back in your wallet without scarifying performance? Forget the old assembly lines with almost 30,000 parts. Musk hasn't been hiring assembly workers for years. At Giga Texas, building the whole body of the Model 2 only needs 50,000-ton gigacasting machines to cast 3 pieces: the front part, the rear part, and the structural battery pack. But why only with this one simple step, Tesla can cut $7,000 off each Model 2? The number of parts is now slashed by 70 times down to just $423, saving about $2,000 in material and logistics per car. Fewer parts also means fewer joints. Each front and rear casting needs around 100 welds. The structural battery pack needs 70. When these big 3 castings come together, they only need 16 welds along with aerospace glue rated at 40 megapascal, holding everything seamless. Compare that to a Chevy Equinox EV or Mustang Mach-E, which have more than 5,000 welds. Just one misaligned weld or tiny crack can cause structural issues. On the Model 2, that number drops by over 91% down to only 300 welds. This also means Tesla doesn't need 40 to 50 workers on the line like they did for the Model 3, Model S to handle welding and quality checks, saving around $1,500 in labor costs per car. Robots and inspection machines don't need to run nonstop either, saving roughly 3 kWh of energy per vehicle. Sounds small, but over a year of production, that's $50,000 of saving. Musk has already promised a price under $25,000 for the Model 2, but with the quiet changes at Giga Texas, production costs could drop enough to bring it down just under $19,000. This doesn't mean you'll get something like colorful boxy EVs from China. The Model 2 frame is cast from aerospace-grade 6061T6 aluminum, heat-treated for a tensile strength of 400 megapascals. A single solid cast of this material spreads forces evenly, eliminating stress points you'd find in traditional welded frames. That's why the chassis can last up to 30 years. And you won't throw away thousands for weld fixes every year. With the structural battery one-piece aluminum frame, the Model 2 torsional rigidity is 30% higher than the Model 3, which already safely handled sharp turns at 60 miles per hour safely and withstood 1.3 tons of pressure without deforming. Even better, the Model 2 could end up being Tesla's lightest frame ever at just 120 kilograms compared to 270 to 320 kilograms current models. That means the car needs less energy to move. And with an LFP battery like the one on the Model Y, its range could increase by about 15%. From roughly 267 miles up to nearly 307 miles per charge. Do you ever get frustrated with all the rattles, squeaks from heavy panels, or constant maintenance on your car right now? Drop Model 2 in the comments if you're excited for its launching to replace all that annoying problems. 2. How will Tesla's copy-paste factory make the Model 2 cheaper? Every month after launch, Why can a Model 2 keep getting cheaper even after the first cars roll out? Because at Giga Texas, the factory itself works like a product you can copy and paste instead of one giant fragile line. Tesla builds the car in parallel cells that click together like blocks. Each casting cell has shared utilities and quick swap dies. So when demand rises, you do not redesign a building. You add another cell that keeps tasks steady and uptime high. Unboxed assembly keeps parts moving in short, straight paths. Sub-assemblies meet only once at the end. So you remove long conveyors, overhead carriers, and miles of wiring trays. Cut 20 to 30% of the body and paint footprint, and you cut millions in yearly building and utility costs. At volume, that alone can trim low double-digit dollars per car before you touch labor. Paint also gets simpler. Fewer color recipes and single-pass curing reduce rework, which saves time and energy on every shift. Changeovers are faster, too. Quick swap casting dies can drop changeover from about 45 minutes to about 12 minutes. With several changes per day, that returns more than 3 hours of live production time. At roughly 55 castings per hour, that is well over 150 extra castings each day without hiring more people. More output on the same floor means fixed costs are spread over more cars. Now look at what sits around the line. Suppliers for bulky parts move inside the fence or within 150 m. Seats, HVAC modules, and drive units travel by truck once, not back and forth across the country. That cuts packaging and freight by about $150 to $250 per car and frees up several days of working capital. Inline vision catches flaws early. Lift first pass yield from 93% to 97%. And you avoid roughly $200 of scrap and rework on a typical $5,000 body and white cost base. Ramps that used to need 9 to 12 months to settle can land near the target in 4 to 6 months because Tesla can copy exact a tuned cell and drop it into the next bay. Digital twins test die fill cooling robot paths and AGV traffic before metal flows. Pulling 100,000 cars forward by 2 quarters reduces idle capital and interest expense, which amortizes to more dollars saved per car. Add the smaller building, faster changeovers, local suppliers, and higher first-pass yield, and the factory system can peel away hundreds of dollars per Model 2. That is how a sticker under $20,000 becomes real while quality and safety go up, not down. How can each Model 2 be built in just 4.7 seconds to reach U.S. drivers by 2026? After seeing Tesla's sales fall 13% in the first 7 months of 2025 and BYD's sub-$10,000 models dominate, the launch of a truly affordable car later this year is almost certainly part of Musk's plan to win back the domestic markets. That's why we can count on the first 3 million Model 2s in the US in less than 2 months, just as cheap Chinese electric cars are shut out by new 250% tariffs. Is that out of reach? Not with everything Tesla already has at Giga Texas right now that can crank out cars more.